Now then, this video is going to be about numerical methods as used in FP1. I'm going to cover a number of things across this video, namely proving roots, bisection method, linear interpolation and Newton Rhapson's iterative method. The only thing this video will not cover is Euler's step by step, so if you are looking for that it may not be advised to watch this as it will not be covered. But anything else, yep, why not? Watch it, see what you think. We are given the equation x to the power of 5 minus 5x plus 6 equals 0. Now, the first thing a question is likely to ask is, show that alpha lies between -1 and 2. Now, there's an easy way of doing this. Now, what we do is, if we need to show that the root is between -1 and 2, then what should happen is one of the values should be positive and one of the values should be negative. So we'll see what happens. -1 to the 5 minus 5 lots of -1 plus 6 equals, just quickly type that in on my calculator, power of 5 minus 5 lots of -1 plus 6 gives us an answer of 10. This is our positive value. If we were to put 2 in, or should I say, sorry, that should be -1 and -2, which completely changes the question. Gives us -2 to the 5 minus 5 lots of -2 plus 6 equals, so let's put that in quickly, -2 to the power of 5 minus 5 lots of -2 plus 6 equals -16. Now we know that this is the case because one value is negative and one is positive. And one is positive. So that is how you would show that the root lies between -1 and 2. So yeah, not a problem there. So all we had to do was take our values of -1 and 2, plug them into a formula, see what happened. Now the next part says use the bisection method to find an interval. In fact, we'll just write it. The chances are they will want you to do something with bisection, so bisection method. And we're going to say an interval of 0.25. So what we'll do is we'll take -0.75 as our first value, and therefore what we can say is that if it's, so we're going to do -0.7, sorry, that should be -1.25, not 0.75, -1.25 all to the power of 5 minus 5 lots of -1.25 plus 6 equals gives us a value of 9.19. Value of -1.5, 5 to the power of 5 minus 5 lots of -1.5 plus 6 gives us, let's just change it, -1.5 5.9, so we know it's not between those two. And then we obviously have -1.75 minus 5 lots of -1.75, which comes to -1.663. Now, sorry, I probably should have made that a bit clearer to see, but all we've done is we've taken it at 0.25 interval gaps, and as a result we now know that alpha lies between -1.5 and -1.5 to -1.75. Now then, Another thing that they like to ask you in an exam is about linear interpolation. Now, linear interpolation basically just uses a formula, and that's all we're going to do. I'm not going to go through the actual theory behind it with you. And this formula is or should I say, AFB minus BFA over B minus A. Now, effectively, what this means is that if we take our original equation, we have an A coordinate of -1, and this gave us 10, and so we know that when A was -1, this gave 10, and B is -2 and gave -16. So that's all we have to do. So we have to do -1 times -16 minus what was it? -2 times -2 times 10 all over -2 minus -1 to give this. So we've got effectively 16 minus -20 over -2 plus 1, so -2 plus 1, and this gives us an answer, of course, of 16 minus -20 over -2 plus 1 equals -36, which does not give us a proper answer, which is slightly worrying. I see. What I should have mentioned was that it should be FB minus FA, as opposed to just simply just B minus A. So as a result, instead of the 2 minus 1, what it should be is it should be -16 -16 minus 10, and that changes our answer completely. Sorry for the misunderstanding. The top part is still correct. It's 16 minus -20 over -16 minus 10, which gives us a different answer, of course, and this gives us an answer of -1.38, which is correct. Sorry for the mistake earlier, that's purely my fault. What it should have been was it should be AFB minus BFA all over FB minus FA. Now, the final part of this, I know it seems like it's going on forever, but the final part of this is using Newton Rhapson. Now, the formula of Newton Rhapson is quite simple. xn plus 1 equals xn minus f xn over first differential f with a line xn. So the question says that we need to use Newton. The question will say that we'll need to use Newton Rhapson, and they'll give us a value. But in this case, we're going to pick x equals -2 to start off with. Now, to quickly write out the formula again, fx equals what is it? X to the 5 minus 5x plus 6, and f dash x is obviously going to be the first differential. So if you want to stop the video and quickly practice your differentiation skills, go ahead. 5x to the 4 minus 5. Now, the first thing, now if we're going to write this out, then we need to make sure we know that x1 is 2, and it wants us to do this. We're going to say that we're going to do this twice. You know, twice to yield an answer. So we're going to do x2 equals -2 minus f when it's -2 over f dash when it's -2. So to put this in slightly more easy to understand terms, we're going to do x2 equals -2 minus, we're going to substitute -2 into the original equation, you know, -5, lots of -2 plus 6, but we also need to substitute it into the differentiated equation, which is, you know, 5 minus 2 to the 4 minus 5. Now, as luck would have it, the original equation we did earlier, didn't we, in part 1, and we already know that the answer is -16. So, as a result, we can say it's -2 minus -16 over whatever the 5 is, so 5 times -2 to the 4 minus 5. which is 75. So we can say it's minus 2 minus 16 over 75. So let's do that. Equals minus 1.78 or 1.79 if we're rounding. So now we just need to do it one more time. I'm sure you can probably work out what to do next. We substitute 1.79 in minus f when it's minus 1.79 over f dash when it's minus 1.79, and this yields us an answer of, well, first of all we need to obviously substitute it into the original equation. So we have minus 1.79 to the power of 5 minus 5 lots of minus 1.79 plus 6 over 5 lots of minus 1.79 to the power of 4, obviously minus 5. So it's minus 1.79 minus 0.074, so it equals the final answer we want is minus 1.716. So just to quickly go over that again, the Newton Rhapson formula is xn plus 1 equals xn minus substituting xn into your original equation over the first differential, substituted that in. We have taken minus 2, we have substituted it into the equation and got a better answer, and then we have done it again for the final answer. The only point I would like to raise still at the end is the formula for the linear interpolation. I got it wrong originally, and for that I'm sorry. It should be A FB minus B FA all over FB minus FA. Thank you very much for listening.